Can you have this message, please?
Teams and what are the drivers to unlock market advantage. Human industry is at the center of global sustainable condition and one of the most energy intensive method of operation of water, especially in the starting process. And as a result, because of the climate change and related topic, customers, regulators, and investors are demanding responsible sourcing behavior, transparency in ESG governance, and sustainable value chain. Through ALEMAI, the core focus of the long-term goal is to work on four pillars. The pillar number one is climate change, aligned with 1.5-degree warming scenario as per Paris Agreement. Circularity talking about carbon and its life. Electricity, as you know, the secondary investment, 5% of the total energy incorporation to primary medium. Nature is all about delivering nature positive outcome and all about biodiversity, water commitment, water positive, and social values which thrive and resilient communities, labor, human rights, and importance. If you see from the market advantage, what does it mean? So market advantage means here that by adopting endorsing the sustainable practices raised by the legislation to comply with the market regulations, for example, CLAC, carbon over digital mechanism, and working, and from the 1st January 2026, it's going to be carbon tax is going to be also annually we are going to shift into the European countries. Like CSRD, which is a similar to BRI in India, and London exchange version for listing the metal plant, and ASI is part of it. Other way, if you understand that financial institutions, investors, they are focusing more on ESG compliance, global bias, resources, access to sustainable credentials, customer demand, responsible lending, and responsible to be integrated as green, low carbon. So all in all, ASI was asked to do business between marketing between segment and open the doors to the rest of the world. So this is not a demand setup. Example, for example, aluminum ASI as a form of operations to together aluminum having those. ASI certification is a factory requirement to particularly listing or brand on aluminum, otherwise they are not going to accept it. Many petroleum companies have already announced their board action and also using ASI standards. Electric vehicles is replacing water and medium electrified. This is an important part of it. Packaging, we're talking about blue cloud certified sourcing, the recycling, like initiatives, fixing initiative and progress. And second, I would say, aluminium as a part of the construction industry is also requiring more responsible aluminium productions and aluminium sourcing. What is actually the soul of ASI certification requirement or standard requirement. These are some of the global energy companies just to name a few, like Daimler, Mercedes, Audi, Tetra Pak. They really transform their company process and how they are maintaining ASI as a prerequisite to work with their existing suppliers and future suppliers. So it's a good marketing opportunity for the company. You want to use backlist and use ASI as a platform, as a mechanism to organize governments and create market competitiveness. There are 11 principles in the race side, 60 plus requirement. Some of the regulatory requirements which are related to the actually industries, for example, sustainability carbon design, the right design profile, in terms of recycling content, in terms of packaging, in terms of transport, in terms of chemical reuse, in powder coating and plating, greenhouse gas emissions, and the criteria number six, principle number six. It's also talking about waste, how we need to minimize our waste to avoid going to the landfill, and talking all about resource efficiencies like energy, water, and in a way, it looks like an environmental initiative, but it also have impact on our bottom lines, creating a more profitable situation for our plants. All in all, these are some of the requirements which, by working on this standard, the industry can improvise on the performance, not only in terms of sustainability, but it have a very big limitations we are properly reporting on. If you have any contact, you can contact us. We would love to help you out, clarify about the recycling. And if you have any questions related to technical which are not with you, you can write your questions to ALEMAI and they can consolidate them from like to us and we will try our best to clarify as much as we can. Wish you all the best with success ahead. Thank you very much.
Well, that was a great message from Mr. Sharma. In case you have any question from against the ocean initiative, you can write it to us on the email ID cca@lmi.org. I repeat, cca@lmi.org. In case you have any questions for ASI, then we will be happy to convey that to you, and we'll get in touch with you accordingly. Thank you. Now, moving on to the next session, we have Mr. Anirban Giri and Dr. Mane Singh from Vedanta Aluminium from the IT sector. Mr. Anirban Giri is a metallurgist with an MTech in material engineering from Indian Institute of Engineering Technology, Shibur, and 19 years of experience in advanced aluminium alloy development and process optimization. And I have Dr. Mane Singh. He is the lead scientist analyst division for Vedanta Aluminium and is driving innovation in high performance aluminium alloy for strategic and industrial application over here. I would like to open the floor for him. Thank you very much.
Good evening, everyone. I will be talking about the development of high-strength sustainable aluminum alloy for superior performance and for specific industrial application. So I will go through it. The introduction of Vedanta Aluminum and its product portfolio, then the approach that we follow for developing any new product, and then we will basically go through the new alloy that we are offering, which is ready to market now. So I will talk about high flexible alloy and Dr. Koyasin. We will talk about the ultra high strength and highly available aluminum magnesium channel. Then finally the way forward. So a diversified product portfolio, which is basically among the world largest, and we are continuously focusing on increasing the value-added product. So our target is basically greater than 1 million ton per annum in the current upcoming years. So this is the broad product portfolio. So starting from the hot metal, that is hot liquid metal that we supply to our customer for any means specific application or for alloying for any application basically. And then the Restora and Ultra, the low carbon aluminum, that is also can go for the similar kind of application. For any kind of application you can use that. And then the aluminum silicon T ingot, that is basically used for the end usage like building and construction, then the automotive segment, and also the electrical appliances, etc. And finally, the rolled product that can goes for the automotive market, for insulation application, and for the power projects, for electrical application, for packaging, and for utensil applications. And the alloy ingot, this is particularly for the automotive segment, and we called it PFA, so primary foundry alloy. So it goes specifically for the alloy wheels and cylinder head applications. Then the billet, which is actually the raw, basically the input for the extrusion industry, and the end usage is basically the automotive segment, the building and construction, the electrical, etc. And then we also produce slabs that can goes for hot rolling and cold rolling, and for the end application like automotive and construction. And then wire rod, this is specifically goes for the overhead power transmission. And the saw ingot, it is also goes for the kind of application like automotive and electrical, etc. Then we also offer the pure aluminum ingot in the form of P1020, P610, P0507, etc. And the flip coil that goes for the steel making. So when we talk about our new product development, so this basically stands on three main pillars. The first and foremost important is basically customer centricity. So voice of customer, that is the most important part for beginning of any kind of new product development activity. And so and value proposition, so we basically co-create with our customers itself, and we engage our customers starting from the beginning of any new product development to the every step of the development. And we also try to build a very long term relationship by providing the relevant solution to our customers. And second is basically the innovation. We foster a culture of creativity and R&D, and we are agile for any kind of development. So basically we are flexible, adaptable, and we try to provide a rapid solution to our customers. And the, we basically try to make ourselves ready for adoption of any new technical emerging technologies. And then the growth mindset, so basically they embrace challenges, opportunity, and to grow and learn, then foster the collaboration and support to achieve common goals by sharing knowledge and experience. And then we try to set very high expectation to our customers. So in the new product development side, in past few years, actually we have developed many novel alloys, and we protected them by applying patents. So here actually we will talk about two such alloys which we have developed, and we also filed patent. So first one is basically highly machinable alloy. So right. So the motivation behind this the project is basically there are limitations with the existing alloys. So currently the available market for the machinable alloys are basically 6262 and 6020. These are the two alloys that are being used as a machinable alloy, which is having lead and tin in it. So lead and tin both are banned currently due to non-environmental friendly nature. So that basically leads to a requirement, basically an increased demand of an alternate alloy solution which is more sustainable and also which demonstrate better or equivalent machining performance compared to these two alloys. And currently 6061 and 6082, these are the two alloys those are being used by automotive industry for this kind of application, but this has certain disadvantages. So it forms long and continuous chips which can become entangled on the tool, and it basically reduce the tool life and delay the machining processes. And also the build up edge which is adhered on the cutting tool and causing the bluntless and poor surface finish in the final product. And due to the above two things, basically it also develop a machining induced residual stress which can affect on the subsequent process and can also cause of distortion and cracking during subsequent process. So the product that we have developed that containing bismuth in 6 series alloy, which forms a low melting phase, which is containing bismuth, which actually get melted during machining and forms a short and discontinuous chips. So if you see the application for this kind of alloy, this is mainly applied for the automotive segment, particularly the brake part and also the AC part and also manifolds and other application like electrical and electronic segment, and also some of the textile industries as well. So this is our product development journey. Basically, we started from the thermodynamic calculation of the alloying element, and based on that, actually we have designed our alloy. Then we have done the casting and homogenization optimization at lab scale and also at the pilot scale. Then we have done the hot extrusion and aging and to get the final product. Then we have done the microstructural characterization and mechanical and machinability study, and finally we have developed the SOP for the plant application. So this is the typical microstructure of our the developed alloy. You can see we can get the precipitates of bismuth and magnesium here, which is having the melting point of 271 degree centigrade to 260 degree centigrade, which is much below the temperature that can generated during basically the machining process. So the usually during machining process, the temperature that get generated is around more than 300 degrees centigrade. So due to the lower temperature, the chips get melted and locally melted and also form the small and discontinuous chips. So this is the mechanical property that we have measured. So the dark blue one basically the representing the 6262, which is the lead and bismuth bearing alloy. And the light blue one is basically the base 6062, which is currently being used by the automotive industry. And the green one is basically the alloy that we have developed. And you can see both the UTS and the yield strength are better than the existing alloys. Then we have done the machining study of these alloys also. So we have tried with 6082, which is the base alloy, and also the newly developed alloy. This is alloy 1, alloy 2 and alloy 3 are basically the same alloy with different composition. So you can see due to presence of the low melting phase, we are able to get the very short and small chips instead of very long and continuous chips in regular 6082 alloy. This is the 3 different machining parameters that we have tried basically, and we have tried 3 different conditions for all the parameter, and you can see very clearly that in regular 6082 in all conditions we are getting only continuous and long chips, and in newly developed alloy you are getting very small and discontinuous chips in most of the cases. So surface roughness is the other parameter that also can show that how basically it is the alloy is machinable or not. And you can see that the first one is basically representing the surface roughness value for different condition of 6082 base alloy, and other three are basically representing alloy 1, alloy 2 and alloy 3. So the newly developed alloy, and you can see that the mean value of all the cases actually shifted towards down. So it has basically lesser surface roughness after machining. And also we have measured the spindle load, and in case of the newly developed alloy, the spindle load is also very less. So if I summarize the entire development, then basically what we can say that due to presence of the bismuth and magnesium phases that are basically low melting phase, and that enable us to basically get a short and discontinuous chips. And the mechanical property side, both the ultimate tensile strength and yield strength, we are getting 80% higher than the regular one, and the significant improvement in the hardness. And if you see the chip formation, so in the regular case we are getting long and continuous chips, while in the modified one we are getting short and discontinuous chips, which ensure better machinability. And another parameter, that is surface roughness, you can see the surface roughness value is low than the regular one, and which is basically 30% better surface finish than the regular one. So this is the highly machinable alloy development. Now the next part is basically the ultra high strength and highly weldable alloy, that will be basically presented by Dr. Moinak Sen. Over to you.
Good afternoon all. So this is another alloy what we have developed in our R&D. So this is a new alloy. This is meant for ultra high strength and highly weldable alloy. So and this alloy's use is mainly on the strategic sectors, that is aerospace and defense. So if we are talking about ultra high strength alloy, there is ultra high strength aluminum alloy. What comes in our mind? Till now, it is the 2 series alloy which will dominate the market. If we talking about that ultra high strength alloy, but there are some of the limitation in the 2 series alloy. The major limitation is it has a poor corrosion resistance because of the presence of copper. At second was, it is a very poor weldability. So if we eliminate both of this problem, we can look to the aluminum 5 series. So aluminum 5 series is a moderate strength but has a very good corrosion property, as well as it is a highly weldable. But the challenge is we have to increase the strength of the aluminum 5 series so that it can match the 2 series. So in this work, we actually develop a modified 5 series aluminum alloy which has a strength comparable to the 2 series with a very high weldability and a very good corrosion resistance. So this is there is a product design. We actually designed that, and the typical application is on marine, aerospace and other strategic sectors. So this is the lab scale, that is a process we have followed. We initially do the alloy design by modeling. There is by ICME thermocal. After that we did a casting and homogenization, followed by, as it is a billet product, it will go to the extrusion. So we did a hot extrusion and the homogenization, and we did the extrudability study. And what we have found that this is the typical microstructure of that alloy. So it is a aluminum 5 series alloy modified by scandium. So you can see the presence of scandium in the microstructure. So scandium is the key factor here, which will actually increase the yield strength of the alloy. And as it is a 5 series alloy, there is no copper it is. So it is a very good that is corrosion properties, and it is a highly weldable. We already that is protected our IP by filing a patent for this one. So you can see the tensile properties of that alloy. So it is far more better than your aluminum 5 series alloy, which is in the extreme left, and which is very comparable to the aluminum 2 series alloy. This is in the extreme right. So this developed alloy has you can say that it is superior to the what is the already existent aluminum 2 series because of its low corrosion and the highly weldable property. And you can see this is the comparison of that. So our newly developed alloy has a 36% higher strength than that is your 5083. It has a that is 95% that is higher yield strength comparing to the 5 series, and it is a very good, it is an weldable, and you can see the corrosion rate is very less in our that is it is in the extreme right. Corrosion rate is very low, which is the newly developed alloy. So this is we offer from our R&D side. one of a new alloy. We can use this in all our strategic sectors like aerospace and defense. We can all it can also act as a, that is your import substitutions. Presently similar kind of alloys are there that people actually import it from Rusal and other countries. So we can also use this as a import substitutions of as an option. And this is the way forward what Vedanta, what we are looking for. So currently we have a capacity of 0.5 mtpa, so we are expanding our billet capacity from 0.58 to 1.25 million ton. So by when we are doubling the billet capacity, we actually also increase our product portfolio. We are entering to a new 8.5 meters very long leg billet. Also we are including 12-inch and 5-inch, the new diameters, into our product portfolio. Along with that, we are also working in some new aluminum alloy, mainly on crash resistant alloy, some advanced 7 and 9 series alloy, modified 3 series alloy, and the ultra high strength billet. So all of this for our customers. So everything is aligned with our customer service. So we are very aligned with our customer service by our dedicated domain experts. We have technical support, and we have a state of that R&D facility, and we are also regularly collaborating with all leading NITs, IITs, and CSIR labs for our R&D work. So that's all from our side. Thank you all for listening.
Thank you very much, gentlemen, for your lovely presentation. Before you go, I mean, we would like to just take some questions from the floor, if any. Anybody has any question from the team, Vedanta? Can we have the mic, please, to that gentleman?
Hello. Thanks for the wonderful presentation. So what is about that 9 series LS you are talking now? What is that 9 series?
What?
In your presentation, 9 series also you are focusing in future.
Okay. You are talking about 9 series.
9 series I am asking.
So any alloy which cannot basically accommodate in the existing series like 1 to 8,
Okay.
that can goes to 9 series basically.
So other alloys you are adding SC means scandium and zirconium.
Yes.
So will they be costly, or what extent you are adding in terms of ppm level? What you are adding?
What extent?
Yeah. So it will increase some of the cost, but the property it will given. So currently in you can say in the strategic sectors, people are using similar kind of alloy. So if you are talking about ultra high strength in the 5 series, so people regularly use scandium. But you can't increase that with the help of scandium and zirconium. And typically for that skin of aerospace and all, for the formability, creep formability, you need zirconium and scandium both. It is from the also from the your mechanical that is property side. It is not only the strength, but if you do that your stretching, if you do the stretching for your that is the forming creep, you need zirconium and scandium for that. So generally if you say that in HAL they are going for the Saras Mk2 that is aircraft, the 12-seater aircraft. So they are also planning using the same kind of alloy for the skin. So when you are going for the skin, you need a that is your forming creep. So for the better forming creep, people use scandium and zirconium. This Al3ZR precipitates that will actually increase the strength.
Addition to that actually, so as he mentioned in the first slide, that 2 series alloy which is currently being used for this kind of application, that has certain limitations. So these are not weldable. So you can see in all cases where we are using 2 series alloy, it is being riveted or mechanically fastened. So this alloy actually can give you the similar kind of mechanical property. At the same time, it has a better fabricability due to the weldability. So that is why the cost will be slightly higher than the 2 series, but it is not much higher. So we have optimized the composition in such a way so that it can, so should not go much beyond 2 series alloy.
I'll visit your stall, personally interact with you. Thank you.
Okay, any other question from the floor? Okay, then we will call it a session. So thank you very much, Mr. Giri. Thank you very much, Mr. Sen. Before you move on, we would like to just. We have our next speaker, Mr. Pankaj Nirmal. He is Deputy General Manager, Engineering Design and Simulation Center at the Automotive Research Association of India, Pune. With over 21 years of experience in automotive and non-automotive product designs, including defense and bus body development, Mr. Nirmal is a specialist in lightweighting solution and has led numerous projects using experimental and CAE techniques to improve product life and structural performances. I would like to invite Mr. Nirmal on the stage, please.
आई थिंक एचडीएमआई सही से नहीं लगी एक्सटेंड कर दी यार फुल स्क्रीन कहाँ से होगा सर ये फुल स्क्रीन क्यों नहीं हो रहा तभी तो हुआ था फिर से कर नहीं नहीं ये पीपीटी फुल स्क्रीन क्यों नहीं हो रही
Thank you. Hello, everyone, and good evening. Thank you, ma'am, for introduction. Uh, the topic of today's presentation is role of aluminum extrusions in lightweighting. In this presentation, we'll be discussing about the projects that we have carried out through lightweighting. I'm represent. Okay. Uh, I'm presenting this presentation on behalf of my organization, ARAI, the Automotive Research Association of India. It is located at Pune. ARAI is established in 1966 and is expertised in prime testing and certification agency, as noted in CMVR rule number 126. At ARAI, we provide integrated services related to certification and standardization, research and development, engineering services, and education and training. Coming to the topic of coming to the topic of lightweighting, uh, lightweighting is a prime factor. Lightweighting is the prime parameter for in automotive sector. We always come across various things like how much mileage a vehicle gives. So lightweighting is directly related to the mass of the reducing the mass of the vehicle. The lower the mass, the more fuel efficient a vehicle can be, and it can also reduce the emissions. By lightweighting, we can reduce the wear and tear of a vehicle, uh, and also reduce the uh, replacement of the tires per mile. Lightweighting can lead to increased payload. The amount of weight reduced can be considered as the increased payload. Lightweighting can be carried out through various by adopting various techniques like adopting the right design tools like topology optimization, by having simulation driven design where we can identify failure at much initial levels and solve the problems. Also, material selection is one of the parameter in lightweighting, wherein we can select material based on the application of the component of it or the subsystems, which has high strength to weight ratio. Again, while lightweighting, we need to consider the manufacturability of the that particular component, like whether we have to go for forging or casting, or we want to use sheet metal components. These all can be considered at design phase itself. Apart from this, while developing a product, we need to understand what are the joining techniques, what are the tools or fixtures required for handling those components. So based on this, we feel aluminum is the right candidate for lightweighting, as it can be aluminum can be formed into casted components, forged components, can be used as a sheet metal component, which are very much suitable for producing automobile components. And as it has high strength to weight ratio, it can be recyclable, it can be extrudable, and it is corrosion resistant and also available in a large scale in India. So based on these parameters, we thought to have a direct application-driven thing on taking this topic forward. So we thought when we started this lightweighting project, we had a clear motive that it should benefit the nation, it should contribute in the nation's growth by reducing the fuel consumption by the vehicle, and directly impact reducing the import duties that we pay for importing fuel. Then through lightweighting, the emission targets which we have set for reducing the emission targets, that should also be achieved. Also, the motive behind lightweighting project was to bring aluminum extruders component manufacturer to the mainstream and come up with the techniques where we can have a better product for the public. So we decided to have a bus as a segment wherein we can have all these lightweighting benefits on a larger scale, because city buses if you take any city, there are almost 3,000 city buses are daily running, which covers almost 200 kilometers with frequent starts and stops. These buses contribute to maximum emissions, which is around 23%. So if we reduce the weight of city buses, we will surely come up with the benefits of lightweighting. So we took this forward and studied the complete a bus assembly, wherein we identified the superstructure contributes the maximum weight, and out of which body frame contributes almost 60% of the weight. So we decided to design a new lightweight superstructure for city buses. For doing so, we created various ideas for extrusions, extrusion designs, joinery design, and decided to take it forward based on the experimental experiment that we carried out at ARS laboratories, where we studied all different types of joints of existing steel buses and developed a steel equivalent section, which is steel equivalent section which is very much suitable for developing aluminum superstructures for buses. We took this forward and designed a complete aluminum superstructure for city bus and validated it through simulations. Where we carried out all the regulatory requirements and took this forward and continued discussion with aluminum extruders and fabricators to develop preformed aluminum kit. In doing so, we developed our first prototype of a lightweight city bus, which is a modular in design, which has eliminated almost 90% of the welding, which resulted into having reduced manufacturing timeline, reduced use of electricity, and having a cleaner environment for the workers, as welding is completely eliminated. We captured road load data of existing city buses and took this data as an input to validate our prototype with accelerated durability of 130,000 kilometers, where we found no failures and was taken forward for developing uh, fully functional prototypes. In doing so, we developed prototypes for low floor bus, semi-low floor bus, and staff bus and city buses. This aluminum lightweight superstructured bus has 80% of aluminum, low noise and rattling, high durability and accuracy as it is modular. It is 37% lighter as compared to steel buses, which resulted into 10 to 12% of increased fuel efficiency, and in EVs the range. It has 95% recyclable superstructures. Uh, this complete design is 100% compliance to regulatory requirements, and is non-corrosive. This particular design, we have received a patent, and also recently we have been awarded with Golden Peacock Award for innovation for product and services. After completing the lightweighting for superstructure, we took this forward and targeted one more application, that is lightweight seats for passenger buses. This project we are carrying out in with JNR-DDC. The prototype of this lightweight city bus is already ready, and we have applied for patent. This is completely modular structure. Welding is eliminated. we have used mechanical fasteners for joining, and this frame of seat is 33% lighter than existing steel frames. This particular assembly, being modular, can be assembled at bus body builder location, which reduces the cost of transportation and service. We have we have carried out a durability test of this seat in our labs using the specified road load data from OEMs, and we observed no failure and no loosening of the bolts. And now this prototype, for fully functional photo prototype is in we are producing it, and soon it will be ready for production. Apart from this, for lightweighting, we have worked with the industry, wherein we have resolved field failures through our design and simulation activity. Through, through our work on lightweighting, we at area are trying to bring aluminum manufacturers, extruders, and bus body builders together to have a greener future in transport section. Thank you.
Thank you very much, Mr. Narmal, for your presentation. And do we have any questions from the floor for Mr. Nirmal? Okay. Anyways, thank you so much for your time and for this presentation. We would like to just give a small vote of thanks from our side. So, well, friends, this was the last session of the day, and we would be closing for now. Tomorrow, we have a power pack day with a panel discussion and also a lot of technical presentations from our distinguished speakers. So, please do join us for tomorrow, and the conference will start at 10 a.m. at the same place. Thank you very much.